Hello and welcome to my YouTube channel. It's another great day where we have to learn mathematics, making maths easy for everybody. Now, if you have not subscribed, please do so that you will be notified on our next video. We move straight to the point. Angles of elevation and depression. So let's say given the figure below, something like this, or a swoop upward. Let's bring it down like this, moving like this. Let's trace this. Okay. Let's assume this is a flag. Okay. So this angle, let's say is angle A. Now, from this diagram, you see that this person standing here is trying to look at the top of the flag. So this line of sight forms an angle to the horizontal. This is the horizontal line of sight, and this is the slant line of sight. So initially, the person can look horizontally to this point. But since the person decides to look at the top of the flag, it forms an angle with the horizontal. This is the horizontal. So this angle formed is called the angle of what? Elevation. So this angle from this line of sight to the horizontal is called angle of elevation. So that's just it. Now, when we want to explain angle of depression, okay, let me draw downward. We say given the figure below, let's say this, so let's assume this is a car. Okay, pardon the way my car looks. Now here is another person moving like this, is the horizontal, but the person is looking downward this way. Probably because the person is taller than the car, or the person could be standing on an altitude higher than that of the car. It doesn't matter. But provided you're looking down this way, it forms an angle of depression to the horizontal. So this is the horizontal on the person's side, and this is the slant angle of sight down to this car. So this is the line of sight. So the angle it forms to the horizontal is called the angle of what? Depression. So I call that B. So now there is a relationship between the angle of elevation and that of depression. So let's quickly use an image to illustrate that. So using an image to illustrate that, let's assume this is Mickey or Mimi. This is Mimi and this is Mickey. Probably Mickey is the junior sister to Mimi. Mickey. Okay? So now Mickey decides to look upward this way and looks, of course, the horizontal line will always be there, like this. And then the horizontal for Mimi is this. So watch. Mickey has an angle of elevation and Mimi has an angle of what? Depression. Mimi's angle of depression is this. We call this B. And Mickey's angle of elevation is this. We call it A. So we simply say that the relationship between angle of elevation and angle of depression is that they are alternate. What do we mean by they are alternate? When you do normal geometry, if we bring out this is a parallel line that is cut across by a transversal. You see that? So that's what this is. So this angle is alternate to this angle. Therefore, we say that A is equal to B because alternate angles are what? Equal. So that's it. So in another way, we'll say that angles of elevation and depression is one of the application of trigonometry. So we see that on these examples. You can always pause this video to play and to understand. Or better still, replay. Now, we have the distance of a boat from a bridge 120 meters high above sea level is 200 meters. Second thing you have to take note of is your ability to interpret the question. Like this question now, we are saying that the bridge is 120 meters high. We have not discussed the distance yet. So the distance of that boat from the base of the bridge is 200 meters. That's what it means. So whenever you're discussing angles of elevation and depression, the simple thing you need to do first is whenever you cite the word elevation, it is better you draw a right angle triangle in this form. Okay? So if you draw it in this form, this becomes the angle of what? Elevation. This way. So let's call this theta. We are trying to explain this question now, or interpret the question. So the question says calculate the angle of elevation of the bridge from the boat. So the height was given to be what? 120 meters. And the distance from the base of the bridge, this is the bridge, here is the bridge, and here is the boat. So the distance from here to here is 200 meters. The question is, what is the angle of elevation formed? Now, what do? We use our trigonometric ratio, which we know as SOH CA TOA. Now, it may interest you to know that in solving angles of elevation and depression, we may not really need to use these first two, because angles of elevation and depression really don't talk about the slant height, which is the hypotenuse. So we may not really need SOH and CA, but TOA will always come to play. So this is going to be tan theta equals opposite over adjacent. That's what TOA means. So our opposite, this is opposite. So opposite to our angle here is 120 meters. So this becomes tan theta equals to 120 all over 200, which is the adjacent, 200 meters. So this cancels out. We have 12 to 20. 4 here is 3, and 4 here is 5. So this is invariably 3 over 5. So if we divide 3 over 5, this is going to give us tan theta equals to 0.6. Now what we are looking for is the angle, which is theta. So what we simply do is to look for the tan inverse of theta, so we can get theta. So if we are multiplying through by the tan inverse, I'm trying to maximize my board. If we are multiplying through by the tan inverse, that is tan power minus 1 into tan theta equals to tan inverse of 0.6. This cancels out to give us theta alone to be equal to the tan inverse of 0.6. So if you're using a calculator, tan inverse of 0.6 is equal to 30.96. So this is approximately 30.96. So this is the angle. That means the angle is what? 30.96 degrees. So simple. Because we were able to interpret the question. So let's solve the second question. I'll clean this. Okay, question number 2, solution 2. Let's draw this to manage the board. Says the angle of depression from a lighthouse to a boat is 30 degrees. So here, the angle of elevation or depression rather was given. So what is the question? If the lighthouse is 50 meters high, the height was given, how far is the boat from the base of the lighthouse? Tan 30 degrees is 0.577. Okay, it has been given. Now, what we are looking for is the distance of the boat to the base of the lighthouse. So, we can do this. Or we can still use the former triangle I used just to conserve space. Let's do this. Okay? So we can say that the lighthouse is, remember I use this for angle of elevation. Okay? Now, I want to use it for angle of depression. How do I do that? For angle of elevation, the angle is here. But when we want to use it for angle of depression, the angle should be here. Meaning, this is where the lighthouse is. And this is where the boat is. Okay? Good. So, they say this is 30 degrees. And the height is what? 50 meters. So, here is what? 50 meters. That is this place. The distance is not given. So let's say let this distance be what? Y. So if the distance be y, using saw catua again, tan, remember, is what we are going to use. So tan 30 is equal to, the opposite now is this, which is our y. Opposite over adjacent, which is what? 50 meters. Now, tan 30 was given from the question to be 0.577. So this is 0.577 equals y over 50. So what we do now is to cross multiply, meaning y will be equal to 0.577 times 50. So if we multiply that, 0.577 times 50. This is 28.85. So y is equal to 28.85. So approximately y should be equal to what? 29 meters. So if you find this video interesting, please like, share, and also don't forget to subscribe so that you get notification on every upload of new videos. Thank you and bye bye.